Welcome everyone to the series of lectures on large language model. Now this is lecture 5 in this series, which is the successor to the previous lecture, which was on pre-training and fine-tuning. In the last lecture, we understood what is the difference between pre-training and fine-tuning. You also understood that is it necessary that every model need to be fine-tuned or not? And is it necessary that every model need to be like pre-trained or not? What we understood that yes, it is necessary that every model has to be pre-trained on large data set, and the model should be large. Large stands for large parameters. Then only we can call it as a large language model, or we can create a base model. And then we discuss whether we can fine tune or not. Now, this lecture is again a comparison between fine tuning versus zero shot learning, one shot learning, and few shot learning. And it is very important to discuss because it has actually changed something significantly in the way we interact with the large language model. This paper, one of the paper got published in 2020 by OpenAI. This paper got published in 2020 by OpenAI. It says large models are few shot learner. Large models are few shot learners. Now, if you read this paper, it is a very interestingly written because it has some very beautiful charts, very beautiful tabular information, and very easily written. It is not written like any other paper which throws information in a very convoluted manner. We'll read the abstract. But what was the core message of this paper? The core message of this paper was that it claims that fine tuning is not required. A very big claim, but they were claiming that fine tuning is not required. We don't need fine tuning. No fine tuning is required. We just need prompting. And this paper was the first paper which gave birth to the modern LLM. You know how this paper, GPT-3 model, because this paper introduced GPT-3 model and how it has changed everything around how we interact with LLM model. Yes, the 2017 attention all you need, the paper by Google has put on the foundation that how the model architecture need to be designed for LLM, but this actually changed how we interact with LLM. So these two papers are like the paper who put down the real foundation of modern LLM. We discussed about 2017 paper in the previous lecture, so refer to them. Now that's why in the modern LLM, we talk about prompt engineering, chain of thought, tool usage, agents, and instruction tuning because of this paper. Because this paper introduced something which is called as prompt engineering. We're not specifically calling it as prompt engineering. Rather, they were calling it as zero shot learning, one shot learning, and few shot learning. And I have taken all these images, all these examples from this paper only. All the tabular information that you see on the screen is from the paper only. These are the snippet from the paper. What is zero shot learning, one shot learning, and few shot learning? At a thematic level, they are prompts. But what is so special about the prompt? This is the first time any LLM researcher did a research that you can also get the desired result, optimum result from the model without fine tuning. It actually challenged fine tuning by saying, hey, why not you give instruction without example? That is zero shot learning. So when I say zero shot learning, it says that you have to provide instruction. Instruction. Whenever I say instruction in the LLM world, in the LLM genre, we say task information. So instruction, task description or task information, what the model has to do. So provide the instruction and provide the prompt. You don't provide any example. We all know that most of the large language model, the initial large language model, were designed to translate English into French, English into German. So the instruction this paper gave to GPT-3, which had 175 billion parameters, they said, hey, you have to translate English to French. This was the instruction on the prompt. The way you interact, the same prompt. And they gave the word cheese. No example. So that's why this is called as zero shot learning. What is one shot learning? Similarly, you're providing instruction. What translate English to French? There's nothing different. You're asking to translate English to French. That is the task instruction. and you gave one example. One example, this is a word or two word in English, and this is the translation in French. And then they are asking for translate cheese into French. This is one shot learning because only one example was provided. Then they tested how it will perform, how GPT-3 model or LLM model will perform if I provide multiple examples with instruction. Instruction was same or identical, but more examples. And then the same task, you have to translate English to French, and the word is cheese with three examples. Actually, it could be 10 to 100 examples. And that is called as few shot learning. So what is zero shot learning? No example. One shot learning, one example. Few shot learning, multiple example. Intuitively, you would say the performance will improve. We have, if we move toward few shot learning, and actually that happened. But the intuition in the world of research is not sufficient, right? Definitely what happened, and this paper is also talking about the same, is that the performance of the large language model, thematically, if in one line you want to just summarize the paper is saying that few shot learning is working better than fine tuned model in some of the cases, and also performing in some cases as the best model, even if you compare the model which are fine tuned or implemented RAG. And these are the testing evidence. So they tested the model first, GPT 0 shot, GPT-3 1 shot, GPT-3 few shot. What is SOTA? At the time when this model was written, that is 2020, SOTA was the best fine tuned model. So SOTA is the model which has pre training and fine tuning both. Okay. You see the performance. You see the performance. When it tested for Lambda, what is Lambda? We'll talk about it. When it was tested for Lambda, the performance you can see is best for few shot. When it is tested for story close, yes, the performance was not best for few shot, but for SOTA, but the second best was few shot. And when it was tested with a benchmark HELA-SWOG, then again the SOTA was performing the best, but yes, the few shot learning is the second best. Now, what is this Lambda? What is this story close? And what is this HELA-SWOG? These are the different way to test the model. So basically, if in one line I have to summarize what Lambda does, and it is also written here, that it tests whether the model is understanding the whole context or whether the model is just having a secluded information from the whole text and not understanding the whole information that is being provided to the model through the prompt. And what they have understood that yes, the few shot learning is working pretty good in the terms of accuracy. What is story close? Another benchmark. These are not large language model. These are the testing framework. If you want to understand at a very high level, these are the testing framework. So when it was tested for story close at it, as the name suggests, it tests whether the model is understanding the story and whether that story, whatever it is as understanding, has a logic or not. And HELA-SWOG is generally testing whatever the model is throwing is making sense in the real world or not. Yes, we'll discuss about Lambda, story close, and HELA-SWOG because whatever the large language model we will design, we have to test the model. And we have to design a large language model, that what we have promised here. We will design the large language model from the scratch and we have to test it. So we'll test against these benchmark, these framework. So this was one testing, and you can see that the few shot learning in some cases beating the model which are pre-trained like SOTA. And it was groundbreaking because when you do fine tuning, when you do fine tuning, it needs large data. Whenever the old model go for pre-training, fine tuning, and when they deploy the model, fine tuning lead to a lot of cost. Why? Because you need to provide which kind of data. You need to provide label data, and you have to provide humongous amount of label data. So it is a cost. The problem with fine tuning that we have understood in the last lecture, that it specialized the model. And when it specialized the model, the way it specialized the model, it changes the weight inside the model. Pre-trained decide the final weight, but fine-tuning changes that weight, which is inside the neural network, the hidden layer of neural network. And that creates the problem of what specialization or moving away from generalization, or in the language of machine learning, the problem of the problem of overfitting. The model is specialized, or the model is overfitted model. And what is the problem with fine tuning is that it's not the way we human learn anything. A doctor does not only perform the task of being a doctor by doing MBBS, because in the day to day activity, he has to learn how to travel, how to read the document, how to learn something, how to deal with the technology. So we human learn in a generalized way and also specialized way. We are not a model. The way our brain work is not about it's not only about specialization. It is generalization and specialization, right? So that is the issue with the pre-trained plus fine-tuned model. Okay. And what this paper is saying, okay, you don't have to do fine tuning, because even if in the prompt, if your prompt is providing sufficient example with the instruction, the task instruction, the model will perform accurately. Then the model was tested against question and answering. First, they were asked natural QS stands for natural question, web QS stand for web question, and trivia QA stand for trivia question and answering. And you can see that even here, GPT-3 few shot learning is performing best in one of the cases, that is trivia QA, and performing very near to the best, or the second best and the third best in natural QS and web QS. So, what is the need to bear the cost of fine tuning the model? And that actually changed everything. And then people started talking about what? Hey, you have to provide the example in the prompt. You have to provide right example in the prompt. And that built a new study or a new genre in the field of LLM, that is called as prompt engineering. And people started thinking about chain of thoughts, instruction tuning, tool uses, agentic behavior. And that's why modern LLM is filled with prompt engineering texts, chain of thoughts, instruction tuning, tool use, and agentic behavior. Right. So I know this was not necessary to inform that what this paper did, but we are not just talking about LLM, that how the LLM is today in this world. We are also talking about what was the journey of LLM, why we are talking about prompt engineering, why we are talking about the chain of thoughts, why we are talking about tool usage. Because this paper has proved we don't need fine tuning, which is a costly exercise. So with that, let's read the abstract of this paper, and let's try to understand what it is saying. And do you understand that what this paper is actually saying? The recent work has demonstrated substantial gain on many NLP tasks. Benchmarks. Benchmarks are Lambda, Story Close, Hellas Walk. Benchmarks by pre-training on large corpus of text followed by fine-tuning on a specific task. So they were talking about the historical model. Okay. Well, typically task agnostic in architecture, this method still requires task specific fine-tuning data set of thousands or ten of thousands of example. So they are saying that when you fine-tune, you don't only have to provide labeled information, you also have to provide the task specific information. By contrast, human can generally perform a new language task from only few examples or from few simple instruction, something which current NLP systems still largely struggle to. So basically, they are criticizing still the large language model or NLP are not smart enough or not have reached to the level how the human interact and human learn new things. Here we show that scaling up language model greatly improve task agnostic, few short performance, sometime even reaching competitiveness with the prior best or state of art fine tuning approaches. So this line was very important. So what they're actually claiming that just few short learning sometime is beating or competitive enough to beat the state of art fine tuned model. And that's why people stop talking about fine tuning. And they started talking about prompt engineering, chain of thoughts, tool usage, blah, blah, blah. And that led to what we study today in modern LLM. Okay, with that, I'll pause here. And in the next lectures, we'll discuss more interesting concepts related to large language model. Thank you. Have a nice day.